Hey, we're going to be looking at composite functions. So we're going to be taking the limit of f composed of g of x as x approaches 2. So we've defined our f of x as the square root of x and g of x as x squared plus 2x plus 1. And when we take f composed of g of x, what we're doing is we're going to take g of x, replace this x with g of x. And of course that's what I do here. So this x gets totally replaced with all of this. So I've rewritten the limit as x approaches 2 of the square root of x squared plus 2x plus 1, and it's equal to the question mark. Now I want to take a look at a theorem that we're going to follow. So more generally, we have this theorem. It's the limit of a composite function. If f and g are functions such that the limit of g of x is equal to L as x approaches c, and the limit of f of x as x approaches L is equal to f of L, then we can say that the limit of f composed of g of x as x approaches c is equal to f of L. Well, let's go back to our example. So we have the limit as x approaches 2 of our function here, which is our g of x. And it's equal to 9. We know that because we do direct substitution, plugging 2 directly in, and 2 squared plus 2 times 2 plus 1 is 9. And the limit of the square root of x as x approaches 9 is equal to 3. So looking back here at the theorem, remember that this was equal to 9, and then we took x approaches 9 of the square root of x, and it was equal to 3. So as you can see, that's what we've got written here. So remember that the composite f composed of g of x, and that's what this is equal to f of L back in our theorem, and therefore we're doing the direct substitution, plugging 2 directly in, and we get 3 out. Now remember in the theorem that this was going to be equal to f of L. And that was our L, and if you take our function f, which was the square root of x, and we plugged 9 into the square root of x, we get 3 out. Let's take a look at the graph. So here's the graph of our composite function. We locate 2 on the x-axis and we go straight up. And remember, we said that the limit was equal to 3. We follow it across, and 3 is occurring about right here on the y-axis. Now remember, in these limits, we're coming in from the left and we're coming in from the right-hand side. So if I picked a point to the right of 2, went straight up, as x gets closer and closer to 2, my y value is getting closer and closer to 3 coming in from the right. And then looking at it from the left-hand side, we go up. And as we get closer and closer to 2 from the right, my x value, my y value is getting closer and closer to 3.